famous diagram you would have seen if you are dealing with natural language processing recently. So, this famous architecture on transformers mechanism has many multiple features and key techniques to achieve great results, including ChatGPT. So, let's try to decode those in this series and let's try to understand each of those step by step. So, here let's try to decode add and norm. If you see, this add and norm layer happens 5 times in the transformers architecture. So let's try to decode what are these functionalities and why do we even have these in this layer. Add. Add refers to residual connection, right? As the name implies, we are going to add something. Let's see what are we even going to add. Yeah. So, after we apply linear layers and the ReLU function, we are going to add the past input to the future output, right? So, if we are feeding x as the input, even after multiple layer of processing, we are going to add it back to the future layers so that it becomes the processed x, which is f of x, and the original input x added again to it. But why do we have to do this, right? Because many mechanisms like LSTM or the RNNs, they had a disadvantage with the memory retention. So when we utilize the residual connection, it doesn't suffer with the short-term memory loss. So the past experience also gets added back to the future layers so that the information is retained even after we pass through multiple level of layers. How are we achieving it? We are passing the same information, retaining the same information of x even after the multiple layers using this addition mechanism. So this is referred as add in the transformers architecture. Now let's go to the norm. What is norm? Norm refers to normalization, right? As the name suggests, we are going to normalize all the values that we have in a layer. And why do we have to do this? Because if you do not have uniformity among the data, it might confuse the model and it would be very difficult to reach convergence during training and also in the inference stages. Hence, the usual normalization methods transforms features to a standard scale. So this mechanism helps to reduce the skewness in the data, and it also helps the model to analyze the data in a more better way in a more standardized scale. So hence this add and norm helps to retain the past information and also to normalize the values to a standard scale to better analyze the data and to give very higher performance. So hope we have decoded this add and norm layer in the transformers architecture. Let's decode each and every layer here in the upcoming series. Subscribe to the channel and stay tuned for more exciting news.